Everyone, this is Orekoya Olusegun, Physics Mathematics Fundamentals, Physics Mathematics Fundamentals on YouTube. Please, before we go into today's exercise, do not forget to like, share, subscribe, and click on notification button so that you can have more of my video. Today, the aspect of my YouTube area that we are going to take is physics, and the topic is under what is called radioactivity, and the topic under radioactivity is a half-life of a radioactive substance. What is radioactivity? Radioactivity is defined as the radioactivity is defined as the decay, the spontaneous decay of a radioactive substance. What I mean by that is that there are some elements whose atoms has nuclei that are unstable. So in a nutshell, when there is a disintegration of that nucleus and there is emission of some radioactive substances, then that particular atom is said to be a radioactive nuclei. So today we want to discuss about the half-life of a radioactive substance. I want to derive a simple equation in calculating radioactive half-life. What is an half-life? The half-life is the time taken for a given number of radioactive substance to decay into half of its total number. Like for instance, let me say this particular diagram represents a nuclei, a radioactive nuclei. Now, when this particular substance integrates, the total number of the constituents of this number will reduce with the emission of a stream of particles. These particles are identified to be number one, alpha particle, then number two, beta particle, and number three, we have gamma particle. So now, for instance, let me say I have initial n number of this radioactive substance. It will take certain period of time called the half-life for this substance to disintegrate into half of its value. So the next derivation is that half of this number will become this. We divide this one by 2 again. We have over 4. That's another half-life. Another half-life of this one will become, we divide this one by 2, will become over 8, and so on and so forth. So how do we derive an equation for this half-life of this radioactive substance? Now, experimentally, the rate of disintegration is said to be negative and is directly proportional to the initial number of the radioactive substance present, and this rate is said to be a negative rate of disintegration, and then this rate is minus the n divided by the t, the time. The number of radioactive substance divided by the time is said to be proportional to the initial number of radioactive substance that is present. So I can take this negative to this side, then I have changing number of radioactive substance divided by changing time. Then this proportionality sign, if I remove it, I can have this particular symbol of proportionality. I take this minus half to this side, then n naught. And this particular one is a radioactive decay constant. It is called decay constant. Constant. So now, this particular derivative, I want to take it with respect to the number of radioactive substance. So I take this number, the initial number of radioactive substance present under this place. So I have changing the number of radioactive substance divided by the initial number of radioactive substance present. Then I cross multiply this with this radioactive decay constant. So I have the T there. Now I'm going to integrate both sides of this equation, and then when I integrate this, I take my limit of integration from the initial number of radioactive constant to the number present at time t. Then we integrate this place from when the time is 0 to when the time is t. Now from calculus, the differentiation of this one will be ln of this one from this limit n0 to n is equal to this particular constant. We leave it as it is. Then when we differentiate this place, it will give us t. Then from the limit 0 to t. So if you substitute this limit here, we are going to have minus radioactive decay constant, then times t. Now if you want to evaluate this limit with respect to this natural logarithm, I put each of these inside here. So I have ln n, take away ln n0 is equal to minus this. Now from law of logarithm, when we have something of this nature, it actually means ln n over n0 is equal to minus radioactive decay constant times time. Now this natural logarithm can be written as log of n divided by n0 to base e is equal to minus radioactive decay constant times time. So when we want to take this logarithm to initial equation, we say this base raised to this power. So we are left with n divided by n0 is equal to minus this raised to power t. Now I want to say something. This particular e raised to power that. So now at time t, as time t going to t half, that means this particular n0, this particular n become n divided by n0 divided by 2, then divided by this n0 is equal to e raised power minus that. Now if you look at this one now, n0 divided by 2 divided by n0, we can have it as n0 divided by 2 times 1 over n0 is equal to e raised power minus this t become half, because this t has been changed to Halflife, that is t half. So in this place I'm going to have t half. So I have minus decay constant, then t half there. Now this initial total number cancel for the radioactive substance. So we are having half is equal to e raised power minus this constant, then Halflife. Now we want to make t Halflife subject of formula. So what I'm going to do is to take the ln of both sides of this equation. Ln of half is equal to ln of e raised power minus half times Halflife. Then this, from the law of logarithm, this power will come here. So I'm having minus that times Halflife, then ln e. Then the ln of 1 all over 2 will give us minus 0.6931. When we take this on our calculator, ln of half will give us minus this minus cancel this minus on both sides of the equation. So we have 0.6931 is equal to the decay constant times Halflife. then the lane of E is 1, because according to law of logarithm, log a to base a, which same thing as log any other thing. Let me say root 5 to log of root 5 to root 5 is same thing as 1. So lane E actually means log E, which is 1. So that brings us down to this place as 1. So making T half, that is half-life, sorry, the formula. I have half-life now become 0.6931 divided by the decay constant. So this is the simple steps in obtaining the formula for the half-life of a radioactive substance. Thank you for watching. Please, before we go, do not forget to like, share, subscribe, and click on notification button so that you can have more of my video. Bye. Have a nice day.